Hey, I am Jack. Everyone talks about electric cars like they're the future. Tesla, Rivian, the Cybertruck. The whole conversation is framed as a new chapter. A technological leap we're finally achieving, but the electric car isn't new. It is a century-old idea that actually won its first fight, then lost it in a way that should make you deeply uncomfortable about how technology markets actually work. In 1899, the US Census counted 1575 electric vehicles built, 1681 steam-powered vehicles, and only 936 gas-burning cars. Gasoline was losing, and what happened next isn't a story about better technology winning. It is a story about cost, infrastructure, and marketing, and it ends with a century of delay. Let me take you back. The first electric car didn't appear in Silicon Valley. In 1827, a Hungarian priest named Sunios Jedlik built what may be the first electric motor, and used it the following year to power a small model car. A priest in Hungary with a motor rolling a toy around a room. That is where this starts. In 1834, an American blacksmith from Vermont named Thomas Davenport built the first industrially usable direct current electric motor and installed it on a miniature locomotive running on rails. These weren't cars in any meaningful sense. They were proof that electricity could move something. The fundamental problem was the battery. These prototypes used non-rechargeable primary cells that had to be discarded once discharged. To achieve a fully functional electric vehicle, a rechargeable battery was necessary. And that didn't exist until 1859. For 3 decades, inventors were building cars with disposable batteries. You drive it, drain it, and the power source was done. There was no charging. There was no infrastructure. The concept was technically real but practically useless. In 1859, French physicist Gaston Plante invented the rechargeable lead-acid battery, an innovation that radically transformed the prospects for electric vehicles. For the first time, a vehicle could be recharged rather than requiring a complete replacement of its energy source. That single invention is the unlock. Everything before it was a demonstration. Everything after it became a real market. What is likely the first human-carrying electric vehicle with its own power source was tested along a Paris street in April 1881 by French inventor Gustave. He took an improved electric motor, paired it with a rechargeable battery, and mounted both onto a tricycle. Truffaut rode it down the Rue Valois in central Paris. He tested it successfully and couldn't patent it. So he moved on, adapted the same motor to power a boat, and essentially invented the outboard motor as a side project. That is the kind of speed 1881 Paris was moving at. In 1884, British engineer Thomas Parker appeared in what is believed to be the first known photograph of an electric car, seated in an electric carriage in Wolverhampton. Parker was the man who electrified the London Underground. His company manufactured batteries and dynamos that also powered Britain's first electric tramway. He wasn't a hobbyist. He was the best electrical engineer in Britain, and he turned that expertise toward building a road vehicle. Lord Kelvin called him the Edison of Europe. By 1890, the technology had crossed the Atlantic. American chemist William Morrison built what many consider the first practical electric car in the US. A converted horse-drawn Surrey carriage that could carry up to 12 people and reach a top speed of 20 miles per h-hour. It was essentially a buggy with a battery in it, but it worked, and once Morrison showed it in a Des Moines parade, other manufacturers started paying attention. Around the turn of the 20th century, roughly 40% of vehicles on American roads were powered by steam, 38% were electric, and only 22% ran on gasoline. This is the part most people don't know. In 1900, the internal combustion engine was the underdog. Electric vehicles had cleaner operation, smoother starts, and didn't require the brutal hand cranking that gas engines demanded. Early internal combustion vehicles were noisy and belched smelly exhaust. Electric vehicles were clean, quiet, and easy to handle, and they were fast. In 1898, a French aristocrat named Count Gaston de Choiseul. Loba drove an electric car to 39 miles per h-hour on a road outside Paris and set the first official automobile land speed record. This ignited a competition between the Count and Belgian engineer Camille Genesy, nicknamed the Red Devil for the color of his beard, and the two of them traded the record back and forth through January and March of 1899. 5 record-breaking runs in 4 months, all in electric cars. On the 29th of April 1899, Genesy settled it. He drove La Jamai's Content, the Never Satisfied, to 105.88 kilometers per h-hour on a road near Paris, becoming the first person to drive a land vehicle faster than 100 kilometers per h-hour. The car had a torpedo-shaped body made from an aluminum alloy called partenium. 2 electric motors on the rear axle producing 68 horsepower combined. Its weight of 1.5 tons included 750 kilograms of batteries and 750 kilograms of bodywork, cabin, and motors. Half the car was battery weight, which, if you've been following modern EV development, should sound uncomfortably familiar. So in 1900, you had the fastest land vehicle on the planet running on electricity. You had Thomas Edison publicly stating that the electric vehicle was the superior technology. You had Ferdinand Porsche, the young engineer, who would later found the sports car company by the same name, building an electric car in 1898, and then immediately designing the world's first gasoline, electric hybrid. The momentum was clear. The trajectory was clear. Then it collapsed. The biggest single reason was the Ford Model T. When it debuted in 1908, it had a top speed of 42 miles per h-hour and a theoretical range of 200 miles per tank, twice as fast as the best electric cars and twice the range. By 1912, a Detroit electric coupe cost about $1,200, roughly $35,000 today. The Ford Model T sold for $550 in 1915, and that price kept dropping. Ford's assembly line in 1913 made that gap structural, not accidental. The economics of the gasoline car were becoming impossible to argue with. Then in 1901, massive oil reserves were discovered in Texas, which crashed the price of gasoline. Then in 1912, Charles Kettering invented the electric starter motor for gasoline cars, which eliminated the one genuine user experience advantage EVs had: no hand crank. As late as 1925, only half of American households had electricity, but just about anyone could buy a Model T cheap and refuel it at a nearby gas station. The infrastructure gap was terminal. Every advantage the electric car had built up over 30 years disappeared in about 15. Electric car manufacturers tried to find a new market. They landed on one: wealthy women in cities. Pope Manufacturing devised a marketing strategy to target EVs as the perfect automobile for well-bred women, noiseless, clean, and requiring less manual labor to operate. The strategy had a short-term bump in sales and a long-term disaster. It attached a stigma to the product. Men rejected EVs not for technical reasons, but because they'd been coded as feminine. The slower speed and shorter range, which were real limitations, became proof of the framing. Most women didn't want a slow car with a short range either. Once they got a taste for motoring, they wanted the same freedom gas cars provided. I think there is something important to sit with here. The electric car didn't lose because it was bad technology. It was outcompeted by gasoline vehicles that became cheaper, faster, and more practical for long distance travel over expanding road networks. The key factors were Ford's assembly line cutting gasoline, car prices, cheap Texas oil, and an improved internal combustion engine with the electric starter eliminating hand cranking. None of those were technological failures in EVs. They were economic and infrastructure victories by the other side. By 1912, an electric car sold for almost double the price of a gasoline car. Most electric car makers stopped production at some point in the 1910s. By the 1930s, the category had essentially disappeared. The fastest vehicle on the planet in 1899 was electric. 30 years later, the technology was gone from public roads. What finally brought it back isn't Tesla. The 1973 oil embargo forced governments to fund EV research. GM built the EV1 in 1996, leased it to thousands of drivers who loved it, then recalled every single unit and crushed them, which you can watch in the documentary Who Killed the Electric Car. And then a company called Tesla in 2004 started with the premise that the failure wasn't the technology, it was the product design. If you make an EV that is faster, more desirable, and more expensive than a gas car instead of cheaper and slower, you break the stigma entirely. The electric car existed before the gasoline car. It dominated the market, held every speed record, and attracted the best engineers of its era. It lost not because it was worse, but because the economics shifted against it at the exact moment it needed to scale. That is the history nobody tells you, and it matters because the same dynamics caused infrastructure, and who gets to set the narrative, are playing out again right now, just faster. I'll see you in the next one.